Hi, everyone. My name is Leilani Gilpin. I am a faculty member at UC Santa Cruz, and I'm excited today to talk to you about my research. And I largely look at explanatory artificial intelligence systems. So I work on building the mechanisms for complex systems to be able to explain themselves. And I largely do these systems with three goals. So firstly, I try and build systems that can explain themselves so that society can trust them. And that's to create systems that are able to testify, answer questions, and provide new insights, especially in the case of failure or error. I'm also interested in building systems that use common sense to be able to reason about new instances similar to the ways that people do. A second area of explanatory AI I'm interested in is developing explanations as a common language for debugging and diagnosis. So part of this is building interactive tools that use explanations as an internal debugging language, but also designing systems that articulately communicate with humans on shared tasks. So think about something like an interactive debugger that's giving you actual natural language explanations of what's going on in the debugging process and not just a stack trace. And finally, I'm interested in creating explanations for articulate mechanisms that are robust. So this is in building systems that use both machine learning and symbolic AI, hybrid symbolic learning systems that can solve problems in multiple ways so that they're redundant and they're not prone to the types of failure states that occur in learning systems or in symbolic systems. I'm also interested in creating systems that are robust in the way that they can dynamically explain. So in different circumstances, you can use the same explanation mechanism under uncertainty for safety critical or mission critical tasks. So for example, if we have an autonomous vehicle that's driving in a new environment, it's able to use that same explanation mechanism and develop explanations of what it's doing, similar to the way that we learn to drive in new experiences. And I'm largely interested in exploring this through 4 applications. So I'm interested in general engineering tasks, so complex physical systems. I'm also interested in applying this to opaque systems like deep neural networks. A lot of my thesis work and the ongoing work that I'm pursuing now is on autonomous systems and autonomous driving. And this is all leading towards better error detection, and especially error detection and anomaly detection systems that can explain themselves. If this is the type of work that you find interesting, please contact me through this workshop. You can send me an email below or get my detailed contact information on my website.